Hi, wonderful sixth graders. This video is all about multiplying decimals. So there are a bunch of different ways to multiply decimals and get the correct answer. In this video, I'm going to show you 3 really good methods. Any of these you can use to multiply decimals for the rest of your life. Pick which one makes most sense to you. So I'll show you how you can estimate the product and get the right decimal answer. You can do this thing called moving the decimal or counting the decimal places. You can get the right answer that way. And if you love fraction multiplication, I'll also show you how you can actually turn the decimals into fractions and multiply that way. So let's take a look at each of these methods. Let's first take a look at estimating the product. So when you use estimation as a way of finding the exact answer, this is what I mean by that. So you'll estimate the product so that you know where to put the decimal at the very end. You'll multiply your decimal numbers as whole numbers, pretending the decimal isn't there. Then once you get that product with your whole numbers, you'll put the decimal in the logical place that matches your estimate. So let's look at this example here. 12 and 3/10 times 4 and 2/10. So let's estimate first. So this is 12 and a little more. This is 4 and a little more. Well, I know that 12 times 4 is 48. So something a little bit more than 12 times something a little bit more than 4. I would guess that it's a little bit more than 48. So I'm going to estimate my products around 50. Let's see how close I get. All right. So next is multiply as whole numbers. So I'm going to take all these digits and just pretend they're whole numbers. So I'll do 123 times 42 instead. And I'm just going to breeze through this multiplication since you could do this on your own at home. All right, so I've got 6, 4, 2. Put a placeholder down there since I'm multiplying by 40 now. And I've got 12, 9, and 4. Oops, you can't see that anymore. Sorry about that. Add that all up. I end up getting 5,166. Now, I need a decimal because I'm not actually multiplying 123 times 42. I'm multiplying 12.3 times 4.2. I estimated this to be around 50. So where would I have to put the decimal to make this number close to 50? Well, if I put it here, it would be close to 500. If I put it here, it would be close to 5,000. Those don't work. If I put it here, it would be 51.66. That's pretty close to 50. Here, it would be 5.166. That's nowhere near 50. And here, it wouldn't even be greater than 1. So the only place I can put the decimal that makes sense is right here to make my actual answer 51 and 66 hundredths. So that it was estimating the product. Let's take a look at moving the decimal. This is everyone's favorite way of multiplying decimals. It doesn't really explain why it works, but it's totally fine. Most adults know how to multiply decimals this way. This is a fine method. So in this method, you're going to multiply the decimals as whole numbers, just like the last method. So then what you do is, in order to know where the decimal goes, you count the number of decimal places in the factors, and then make the product have the same number of decimal places as the factors in total. So let me show you what I mean. So we're taking the exact same problem, multiplying these as whole numbers. 123 times 42. I'm going to skip over the multiplication part since we already did that in the last example, and we ended up getting 5,166. but that's not the right answer because, again, I multiplied whole numbers, not decimals. So I'm going to count the number of decimal places in the factors. So this factor has 1 digit in as a decimal. This factor has 1 digit as a decimal. So 1, 2. I need to take the invisible decimal that is at the end here that separates the ones from the tenths and move it 1, 2 back. So my answer to this is actually 51.66 or 51 6600ths. That way always works as long as you remember to multiply as whole numbers and then put the decimal back depending on how many digits in your factors have decimals. All right. So last is the multiply as fractions method. This one works for people who love working with fractions, and some people's brains love decimals, some people really love fractions. So if you like fractions, this one will work for you. So you need to turn the decimals into fractions, multiply, and then turn the product back into a decimal because you'll get a fractional answer. So you have to turn it back into a decimal unless you're allowed to leave your answer in fractions. Sometimes it works better that way. It depends on the problem. So let's take the exact same problem that we've been working with. So we want to turn the decimals into fractions. So this number here is 12 3/10. And this number here is 4 2/10. Now, when I'm multiplying at fractions like this, as mixed numbers, this is pretty difficult to multiply. So instead, I'm going to turn these into improper fractions. 12 3/10 is 123/10. And 4 2/10 is 42/10. You're probably asking, can I just jump straight from this step to this step to this step without this one in between? Yes, you can. I just wanted to show you where these numbers are coming from. All right, next step is to multiply. We know that. But what are you noticing here? Look at the numbers that we're actually multiplying. This is 12.3 is a whole number. This is 4.2 is a whole number. We actually already know what 123 times 42 is. We've just done it twice. It's 5,166. But we also have to multiply the denominators here. So we've got 10 times 10, that's 100. Okay, so this is a fractional answer now, but we're supposed to be working with decimals. So we've got to turn the product back into a decimal. Some of you might be able to jump straight from this fraction into a decimal, but if not, you can take a couple steps. So 100 would go into 5,166, 51 whole times with 66 hundredths left over, but this is now a really easy mixed number to turn into a decimal because I've got hundredths in the denominator. That's just equal to the same number we've been working with, 51 66 hundredths as a decimal. So that was the multiply as fractions strategy. So just to recap, you've got a bunch of really good ways to multiply decimals. Estimating the product, then putting the decimal back in, moving the decimal exactly where it needs to go in the product, and then multiplying the decimals as fractions instead of decimals. So whichever method you choose, that's fine. In these next couple examples, I'm going to do a combination of moving the decimal and estimating the product. Because I think you guys are really good at multiplying fractions, I'm not going to use that strategy here. So let's take a look at an example, and if you would rather pause the video, try it out on your own, then check your work, go ahead and pause it now that you know we're working with 0.9 times 1.07. All right, let's solve this one. Okay, so first I'm going to start just by estimating product, just so I know that my answer is reasonable. So this 9/10 is really close to 1. 1 7/100 is really close to 1. 1 times 1, I'm guessing I'm going to get an answer that is pretty darn close to 1. Let's try it out. So I'm going to use multiply these as whole numbers, then put the decimal back in. So I've got a whole number of 9 and a whole number of 107. If I multiply those out, I get, let's see, 963. But I need to put a decimal back in because that's nowhere near my estimate. So here I've got 1, 2, 3. A shortcut method of multiplying fractions would be tenths, hundredths, thousandths. That's 3 decimal places. So I've got to go tenths, hundredths, thousandths, put the decimal back 3 places. So I have 963 thousandths. Is that close to 1? Yeah, that's pretty darn close to 1. So I know my answer is reasonable. So 9 tenths times 1 and 7 hundredths is 963 thousandths. All right, let's try one more just to be sure. So I chose this problem because this is what your expression would look like if you were trying to say find 3.5% of $15. You end up with all of these zeros, and I've seen a lot of people try to multiply out with all of the zeros included. It's really easy to go wrong somewhere. I wouldn't recommend multiplying with all these zeros. So instead, look, this 15.00 or $15, that's exactly the same as just writing 15 without the 2 zeros there. I don't even need them. So when I multiply these as whole numbers as step 1, I'm going to do 35 times 15. Even though it says 0.00 and I'm maybe working with $15, don't bother with all those zeros. It'll just mess you up. So let's do the multiplication here. I've got 5 times 5, that's 25. And I've got 3 times 5, that's 15 plus 2, 17. All right, placeholder 0. All right, 1 times 5 is 5. 1 times 3 is 3. Let's add those up. I've got 5, 12, and 5. All right. So it looks like 35 times 15 is 525, but now I have to put the decimals back. So let's count how many places. The question is, do I count these two? Even though they're in my original problem, do I count them? Well, the truth is the number I really multiplied was 15. I didn't have to move the decimal at all to make it this 15. So here, these zeros don't count when I'm counting the number of decimals in the factors. So I've actually just got 1, 2, 3 decimals in the factors. So I can go 1, 2, 3. So just to check and make sure my answer makes sense, remember that 0.035 or 35 thousandths is the same thing as 3.5%. So it's like I'm finding 3.5% of $15. So 10% would be $1.50. All right, so then half of that, 5%, would be 75 cents. So I know my answer, since 3.5% is even less than 5%. I know my answer should be less than 0.75 or 75 cents or 75 hundredths, whatever we're working with. And 525 thousandths is less than 75 hundredths. So I'm pretty sure that this is the correct answer. It makes reasonable sense based on what I'm estimating here. So again, make sure you're using one of these good methods when multiplying decimals. Any of these methods is valid. Choose the one that works best for you. Hope this helped. Thanks. Bye.